Control Settings page is where you define how the EMS interacts with each power source and breaker on your site. Each section represents a specific control functionality that can be configured based on your system architecture. Please note that settings can only be changed when the EMS is stopped. The Battery Control tab defines how the EMS manages your energy storage system, setting rated power and energy limits, defining charge and discharge logic, and coordinating advanced functions like time of use or VSG operation. In this section, you must define the rated power, capacity, and SOC limits for each battery and PCS unit. These settings are mandatory for proper EMS operation. The rated apparent power defines each unit's maximum active and reactive capability. The maximum charging and discharging power values ensure the EMS never sends commands beyond what the devices can safely handle. The rated capacity represents the total energy storage available per unit, a key parameter used for SOC equalization between multiple batteries, ensuring balanced operation across all units. Finally, the minimum and maximum SOC limits define the safe operating range of the batteries. The EMS will stop charging once the maximum SOC is reached and prevent discharging below the minimum value to protect battery health. The maximum active power set point change defines the ramp rate for the battery's active power. In other words, how fast the battery's power output can increase or decrease. By default, the EMS prioritizes using PV production to supply the load first, then export excess power to the grid, and finally store any remaining surplus in the battery. When self-consumption priority is enabled, this logic changes. The EMS will feed the load first, charge the battery second, and only inject any remaining power into the grid. This mode helps maximize on-site renewable energy use and reduce grid dependency. Time of use management allows you to plan when the battery can charge from or discharge to the grid. You can define specific time slots for each day group, for example, charging at night during low tariffs and discharging during expensive peak hours. Even when charging from or discharging to the grid is not allowed, the BESS can still charge from PV production or supply the site load. This function helps optimize your site's energy cost while aligning BESS operation with local utility pricing policies. The State of Charge target allows you to schedule specific charge levels for the battery at different times of the day or week. The EMS will automatically try to reach the defined SOC for each period by charging or discharging the BESS accordingly. This feature is typically used in Grid Prime or Genset Prime modes to define a daily charge-discharge profile based on site operation or tariff periods. The voltage-based charging power limit dynamically reduces the charging rate as the battery voltage increases, preventing cell overstress and extending battery life. This section manages how the EMS regulates and prioritizes reactive power when operating in grid mode. The reactive power ramp rate control smooths transitions in VAR output by limiting how fast VAR set points can change, ensuring voltage stability and avoiding abrupt grid fluctuations. When reactive power priority is enabled, the EMS gives precedence to reactive power delivery before active power, maintaining the desired voltage and power factor even during grid events or dynamic load variation. When the BESS operates as a following unit, the EMS can regulate reactive power to maintain voltage stability at the point of common coupling, mainly by adjusting the reactive power output of the PV inverters. You can choose between different control strategies, defined range, or dynamic target, depending on the site requirements. In multi-battery systems, SOC equalization ensures balanced operation by harmonizing the charge level of each BESS. This function is available only when the BESS operates as a following unit, allowing the EMS to optimize energy sharing between batteries. The Virtual Synchronous Generator, or VSG functionality, allows the BESS to behave like a traditional generator by emulating inertia and frequency response. It can be enabled in Grid, Genset Prime, or BESS Prime modes, ensuring dynamic stability across hybrid systems. When active, the BESS contributes to grid resilience by regulating frequency and voltage as a synchronous generator would. The VSG control feature ensures both active and reactive set points are aligned, while the production feedback option allows the EMS to send real-time power data for precise synchronization. When operating in genset prime mode, the EMS defines how the battery interacts with the generator to maintain an optimal loading range. Two main strategies are available: genset loading minimization, which aims to reduce generator runtime and fuel consumption; genset loading assist, which helps stabilize the genset's output by absorbing or supplying power as needed. The low loading threshold sets the minimum the genset should not fall below. Below this value, the BESS begins to charge to raise the load. The high loading threshold marks the upper limit. Above this value, the BESS discharges to lighten the generator's load. With automatic charge and discharge enabled, the EMS automatically manages power adjustments between charging and discharging of the BESS based on SOC and load conditions. This ensures smooth power flow, longer generator life, and stable operation within the defined limit. We've now completed a full walkthrough of BESS control configuration, from defining power and SOC parameters to setting time of use schedules, reactive power logic, and genset integration. These steps ensure reliable performance, efficient energy usage, and safe operation across all hybrid sites. In our next episode, we'll move from following mode to islanding and forming unit control, exploring how to handle black start, source priority, and resilience in off-grid conditions.